Good morning. Welcome to Current Chem World. In this video, let us see molecular orbital diagrams for homonuclear diatomic molecules and how to derive the term symbols for homonuclear diatomic molecules. The molecular term symbol is represented by lambda 2s plus 1 in the upper left superscript and gerade. There are four terms in molecular term symbols. Okay, one is the lambda. This is nothing but total orbital angular momentum quantum number. This is spin multiplicity of the molecular electronic state, and it corresponds to gerade molecular orbital or ungerade molecular orbital. This corresponds to mirror reflection along the internuclear axis of molecular orbitals. Okay, let us now, what is called atomic term symbol? It represents the electronic state of the atom. It represents whether it is in ground state or it is in excited state. From the term symbol, atomic term symbol, we can say whether it is in ground state or in excited state. Similarly, the electronic states of molecules, it is in singlet state or it is in doublet state. The electronic states of molecules are also denoted by molecular term symbols. So, molecular term symbols, they are nothing but represent the electronic states of the molecules. For homonuclear diatomic molecule, only the component of the total orbital angular momentum lambda around the internuclear axis or bond axis can be only considered. So the total orbital angular momentum is equal to sum of the orbital angular momentum of each electrons in the molecule. Therefore lambda equal to lambda 1 plus lambda 2 plus lambda 3. This is capital lambda, this is small lambda. Okay, there are four terms in molecular term symbol. Let us see one by one. Lambda, it corresponds to the total orbital angular momentum quantum number. Okay, 0, lambda equal to 0. For example, 0, L equal to 0 means s orbital. Similarly, for molecules, 0 sigma, and L equal to 1 p orbital, that is pi, molecular term symbol pi, lambda. 2 d, we call it here delta, and 3 phi, f orbital, here phi. These are all Greek letters. Okay, let us now see this term. We have seen this term. Now let us see this term. 2s plus 1 refers to the spin multiplicity of the term, where s is the total spin. Okay, and what is this term? Gerade, ungerade. It means whether the molecular orbital have center of symmetry or center of inversion. Okay, if the molecular orbital has center of inversion, then it is called gerade. If the molecular orbital does not have center of inversion, then it is called ungerade. G refers to orbitals that are unchanged upon inversion. U refers to molecular orbitals that change on inversion. If there are two electrons in molecular orbital, then G, one orbital G, another orbital G, therefore total G is G into G. Similarly, one electron in molecular orbital with U, another electron in molecular orbital U. We will see with example G. G into U, U. Okay, now plus and minus sign refers to reflection. Okay, plus refers to symmetric orbital upon mirror reflection. There is a mirror plane, okay, above the mirror plane, below the mirror plane. If they are same, then symmetrical. We will see with the example with the orbital, molecular orbital diagrams in the next slide. Minus an orbital that changes sign upon reflection. Sigma orbitals, both bonding and non-bonding, are symmetric with respect to reflection along the internuclear bond axis. Okay, now let us understand with the examples what are ungerade, what are gerade orbitals, molecular orbitals, and reflection plus minus, what do they mean? Okay, let us consider oneness orbital of hydrogen, another oneness orbital of hydrogen. When they combine, okay, this is the bonding molecular orbital wave function. This is the anti-bonding molecular orbital wave function. Here plus, here minus. Here the plus refers to the atomic orbital wave function, sign of the wave function. Plus refers to sign of the wave function. Okay, here plus refers to the sign of the molecular orbital wave function, not electrostatic charge, plus charge, minus charge. They represent, plus and minus represent the signs of the molecular orbital anti-bonding molecular orbital wave functions. The wave functions are mathematical functions. They have either plus sign or minus sign. So here plus plus, so plus plus in the case of bonding molecular orbital. And let us see, let us take a point here and you draw a line through the center, and okay, and at the same distance. Now you have identical, this place is identical, same sign. There is no change in the sign. Therefore, it is called gerade orbital. This bonding molecular 1 sigma oneness orbital is 1G. Okay, 1 sigma G it is called because it has center of inversion. Okay, plus sign meets plus sign. See here, plus sign meets minus sign. Therefore, ungerade. The anti-bonding orbital sigma star oneness is ungerade. Okay, U and G represent the center of symmetry. Okay, now let us consider a plane, okay, along the internuclear axis, this plane. You see, symmetrical above and below plane, both are same. Here also, here plus, here also plus, minus, minus. Okay, so sigma orbitals have reflection plus. Let us see here. Let us take this mirror plane. Okay, here you have plus plus, you have minus minus. Okay, not symmetrical above and below plane, so reflection minus for pi bonding molecular orbital, pi molecular bonding molecular orbital. Okay, plus plus this plane minus, and let us draw a line here. Okay, here it is plus, at equal distance you will meet minus. So this is ungerade orbital. Okay, similarly here this is again ungerade orbital G, U. Okay, this is U, this is again U. Okay, now let us derive the molecular, let us draw first molecular orbital diagram for H2 plus ion, molecular ion, and derive its molecular term symbol. Okay. Okay, now 1 sigma G, there is only one electron, so 1 sigma G, one electron. This the antibonding orbital is empty. So the ground state electronic configuration of H2 plus ion is 1 sigma g 1. Okay, therefore sigma s orbital, it is similar to, therefore lambda equal to 0. There is only one electron, therefore s equal to 1 by 2. So the spin multiplicity value is equal to 2 into 1 by 2 plus 1 equal to 2. This is a doublet. Okay, now let us write the term symbol for H2 plus molecular ion. Okay, for this electronic state, this is the term symbol. For this electronic state, this is the term symbol. Therefore sigma spin multiplicity 2 and g, because the electron is in g, so it is g molecular orbital, and then sigma orbital is mirror reflection plus. It should be read as doublet sigma g plus. The bond order is equal to 1 by 2 number of electrons in bonding orbital minus number of electrons in antibonding orbital, that is equal to 1 by 2 1 minus 0.5. Okay, now let us draw the molecular orbital diagram for H2 molecule and then derive its molecular term symbol. This is the molecular orbital diagram of H2 molecule. The ground state electronic configuration of H2 molecule is 1g2. There are 2 electrons. So lambda, the total orbital angular momentum, equal to 0. Yes, this is sigma. And there are 2 electrons, okay, plus of, minus of, therefore the total spin equal to 0. So 2 0 plus 1 singlet. The term symbol is, okay, singlet epsilon, okay, epsilon, and here sigma g, because g orbital 1 sigma g, and it is plus, reflection plus. Okay, now let us draw the molecular orbital diagram of helium-2 plus. Okay, here the bond order is equal to 0. Therefore this molecule is unstable, this molecule is not formed. Okay, what is the ground state electronic configuration term symbol for helium molecule, He2 molecule? The electronic configuration is 1 sigma g2 1 sigma star u2, lambda equal to 0 because sigma, and for 2 electron, okay, here again 2 electron, s equal to plus 1 by 2 minus 1 by 2 equal to 0, therefore singlet, and there are 2 electrons in sigma u star, therefore u into u, for 1 electron, for another electron, therefore g. Hence the term symbol for He2 molecule is singlet epsilon or sigma and gerade, because this is gerade orbit, this is u into u only, but there are 2 electrons, so g, and sigma orbitals have mirror reflection plus sign, so plus. Okay, now helium-2 plus molecular ion. இதுக்கு பார்த்தீங்கன்னா okay, இப்போ this is the molecular orbital diagram. இதில் பார்த்தீங்கன்னா என்ன இருக்கும், ஒரு எலக்ட்ரானை இதில் ஹீலியம் மாலிகுல் மாதிரி தான் ஒரு எலக்ட்ரானை இங்கேருந்து எடுத்துடுறோம். அப்போ 1 சிக்மா ஜியில் 2 எலக்ட்ரான் இருக்கும், 1 சிக்மா யூ ஸ்டாரில் ஒரு எலக்ட்ரான் இருக்கும். இப்போ this is the ground state electronic configuration of helium-2 plus molecular ion is 1 sigma g2 1 sigma star u 1. Okay, அப்போ இது வந்து lambda equal to 0. அடுத்து ஒரு எலக்ட்ரான் தான் இருக்குது, s equal to plus half. அப்போ the spin multiplicity is equal to 2s plus 1 equal to 2. அப்போ இந்த term symbol எப்படி எழுதுறது, சிக்மா, ஏன்னா lambda equal to 0னா சிக்மா. அடுத்து ஸ்பின் மல்டிப்ளிசிட்டி எழுதிக்கோங்க. அடுத்து இதில் ஒரு எலக்ட்ரான் தான் இருக்குது, இங்கே 2 இருந்தனால G ஆயிடுச்சு, இங்கே வந்து U. அடுத்து நம்ம ஏற்கனவே பார்த்துருக்கோம் சிக்மா ஆர்பிட்டல்ஸ் ஆர் மாலிகுலர் ரிஃப்ளெக்ஷன் வந்து ப்ளஸ் தான் இருக்கும். அப்போ திஸ் இஸ் த term symbol for helium-2 plus molecular ion. Thank you for watching. Please share and subscribe. Thank you again.